Hey YouTube, welcome back. Today we have a new problem called add binary. Today we will do the second approach. In the previous video we did this approach. It was cool, but it was quite long, as you can see here. Today's approach, it will be quite like smaller. It will be, I guess, like 15 lines of code or something like that. So the problem number 67, add binary. Given two binary strings A and B, return their sum as a binary string. For example, I have A and 11, A equals 11 and B equals 1, and I will get 100. So if you want to know, or if you want to ask what is a binary string is a string of characters where each character can only be either 0 or 1. In the context of binary representation, O is typically represented the binary digit for 0, and F represents the binary digits for 1. For example, I will give you like a binary string. This is a binary string, and for example, so basically binary strings are commonly used in computer science and mathematics to represent numbers in base 2, which is a binary numeral system. Each character is the string corresponding to a binary digits. So when you read the string from left to right, you can interpret it as a string number. So for instance, the string 1010 represents the binary numbers of 10. And yeah, this is how it works. So let's just try to build the solution. For this solution, it will be way more easy. It will be just basic math solution, but we will use a lot of bitwise operations. So let's start on it. So first I will say const x, which will be equals big integer, which will be equals like I'll say like OB. No, OB should be bigger, and I will add plus A. And the same thing I will do with Y here, and plus B. So basically, what we're doing here, the add binary function takes two binary strings A and B as an input and returns their sum in as a binary string, and we have the big init B plus A, OB plus A, and big init OB plus B. We convert the binary strings A and B into byte integers by interpreting them as base 2 numbers. This step allows us to perform arithmetic operations on the binary numbers. I will create a variable I will call 0, and it will equals a big integer also, and it will be of 0. And the big integer 0 creates a big integer representing 0, which will be used as a comparison reference in the loop. And we will create two variables more. We will create a carry variable and answer, and basically here the carry and the answer the carry and the answer will be responsible for carry, and the answer which will be the thing that we will return. So we will create a while loop, and inside the while loop I will say y doesn't equals the 0, and I will say first I will have answer will be equals x, and I will do this symbol y. What this means? So basically here this is the bitwise XOR operator, and this operator perform a bitwise XOR operation between the binary numbers x and y in the context of binary addition. It calculates the sum of the bits at the current position without considering any carry from the previous position. For example, if we have if x was if x was this and y was and this was y plus y, we will get this. We got this as an answer. So in JavaScript, we can have the second line, which will be the carry. Is that we want to know if we have a carry or not. So I will say if x and y, and I will do the simple big init of 1. What's going on here? So let us try to. First we have this and this we call bitwise AND operator. This operator performs a bitwise AND operation between the binary numbers x and y. It identifies the position where both x and y have ones, indicating a carry in the binary addition. This section, this is a bitwise lift shift operator. It shifts the result of the AND operations, which is a carry, one position to the left, and this shift corresponds to the carry generated in the binary addition. For example, if the AND operation results, for example, like something like results, if the AND operation results something like let's just like that, the big init operation would make it will just shift it, so it will be like that, and effectively moving the carry on one position to the left. Okay, and after that we will have the x will equals the answer and y will equals the carry. So x equals the answer. It's basically we update the value of x with the calculated answer. This step prepares x for the next iterations of the loop, taking into account the partial sum at the current position. And y equals carry, we update the value of y with the calculated carry, and this steps prepares y to prepares y for the next iteration for the loop, ensuring that any carry, including the addition, in the addition. So right now we almost done. So when we finish this loop, I guess that we could once we finish the loop, we return x, and we convert it to string, like we return x dot to string, and we give it something called 2. So what's happening here? So basically, once we contain the results, once we finishing, x contains the results of the addition in the big line in the big integer format. We convert it to a binary string, use a toString, and we have 2, and this is the way that we convert it, because the thing is 2 is based on 2, and we return the results. So let's just try to submit the code and see if it works or not. And it didn't work at all, because we have what cannot convert OB. I don't know what's going on. Let me try to see it again here. Tak. Let me see. I guess I know where's the problem. Maybe because I need to do it like that. I guess it should be like that. Let's just try to submit and see. Yeah. This is the way. That was wrong. So yeah, that's it for this video. And I guess the thing that I go about this one, that you deal with a lot of operator in terms of the bitwise manipulation way. So yeah, I just try to, if you don't understand anything here, just see the video more than one time, and just give it a time. And that's it for this video, and I hope my description was quite good. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video, and see you guys in future problem.